all this big giant crap over here.
Yeah, with two things at the top.
It's gonna look like that, right? Uh-oh. Like that. Is that right? Can you see up here that I'm gonna put a double bond here and a double bond here?
Yeah.
Mm-hmm. So this is what it should look like, right? My bond in between is just a little bit longer. Yes, no, maybe.
Yes, sir.
Oh, all right. Any questions about the cyclo addition? That's some things that I didn't talk about, but for the sake of time, I'm gonna leave them because there's some other concepts that are associated with this reaction. But I'm gonna stick to the basics just for the sake of time, so we can get through this and get to the next concept. And I want to say for aromatics, which is I think that's the next unit. That's going to be really quick. We'll do aromatics real fast, and then NMR, and then we got a last set of reactions that we're going to do. So it's a bunch of different reactions, but I have a handout for that, and it's got all the reactions on it already. So don't panic. All right. Any other questions about the 4+2? Anything that is not sticking, or anything that you want to ask before we move on to another topic?
So real quick to clarify, you said that the bridge always goes back to the diene for retrosynthesis.
Well, that's kind of I don't like to make general statements like that when it comes to chemistry.
Mm-hmm.
But for these examples, we'll say yes.
Okay.
For the examples that you'll see on the exam or quiz or something like that, we'll say yes. Okay. But in general, we can't say that because sometimes the diene might be, the dienophile may be a 5-member ring, right? And the double bond may be in a place where the bridge is on the dienophile side. So I don't want to generalize like that.
Okay.
Yeah, but for the scope of this lecture and the stuff that we're gonna talk about here, we'll say yeah. All right. Let's see if I can. Is that on here? Oh, it's at the beginning. Sorry. Hope y'all don't get dizzy with me flipping through here like this. All right. So this is the second topic, which is addition. This is a little easier than cyclo addition 2. Conjugated diene. My handwriting is horrible. All right. So let's look at this top example. This is just a refresher, just to jog your memory. Right? What is the product of this reaction? Well, if I take DBN, which is a strong base, very strong base, and react it with this compound, this allylic triflate, what should I get? Don't think about it forever. Think about it for about 30 seconds. This would be a good place to chop the video, so you could take longer than 30 seconds. What do I get when I have a base in the presence of a good leaving group? A strong base. Speak up.
Elimination.
Elimination. What type? If there's a strong base involved, then it's not E1, is it?
E2. E2.
E2 is E2 elimination. So let me zoom in here. Hopefully that's not too big. I'm gonna erase all this stuff. Come on now. So the base is gonna come in and do proton transfer right there. Is that right? If this is my leaving group, what do we call this hydrogen over here that's adjacent to it?
Okay.
Is it the alpha hydrogen?
Mm-hmm.
Man, spring, boy, them 2 weeks of spring break hit hard. All right, I said I was gonna not be sarcastic for the rest of the coronavirus pandemic.
Now you know you're not finna do that.
You right. You right. I'm not.
Not about to last.
Say what? What you say?
That is not about to last at all.
It ain't. Nah. You're right.
Definitely not.
Oh, thanks. Wow. Even people talking that ain't talked all semester. Thanks a lot.
Oh, wait, hold on.
I'm joking. I'm joking.
You're very funny.
Yeah. That's you? Is that you, Cisco? Is that right? Is that the product?
This is Johnny.
Oh, Johnny. Yeah. Oh, yeah. Well, you already know how we go.
I know.
It's static. It's always some static. I'm messing with you, man. Is this the product right here?
Yep.
Yes, I think. Can you draw the extra stuff
What
that's
extra?
gonna happen
What
from
extra
the
stuff?
reaction?
I'm tired now. I've been on vacation now. I got to get warmed back up. So that's coming off. That's my leaving group, right? And then this is the conjugate acid, because DBN is a big giant base. I don't feel like drawing all that. And then of course these two will probably end up doing proton transfer. But those are the side products. The base is gonna pick up the proton, and then it's an E2, so it's like a cascade. Excuse me, where once you break that CH bond, those electrons are used to make the pi bond here, and then you also break this bond, right? It all happens at the same time because it's all concerted. Yes or no?
I'm sorry, can you repeat that?
About the mechanism being concerted?
Yeah.
Yeah. So it all happens at the same time, right? The base.
Yeah. Oh yeah, never mind.
Yeah, the base is going to come in and take off the proton. That's going to cause this pair of electrons to come here. Put a pi bond here, and then you're gonna this pair of electrons is going to leave with the leaving group. That's why I have it negative down here. That's a good refresher. Maybe on a test. Maybe.
Wow.
All right. Let's look at the next question, because that was intended to be like a refresher, just to jog your memory. But let's look at the next question. Can you answer that question?
It's conjugated.
Is it a conjugated diene?
Yes.
It
Yes.
is, right? All right. And let me say that about the diene part too, because I may not have been as clear about that up front. Because it was just one of those. It was kind of hectic. But when we say conjugated diene, what we're talking about is two double bonds separated by, or two pi bonds separated by a sigma bond, right? Hopefully that's clear. That when you say conjugated diene, it can be any structure as long as you have a pattern of alternating pi, sigma and pi bonds, then you can call it a conjugated diene. So the answer is yes. Right? So now this is I just put that in again as a refresher. Get your mind right, because you can't forget E2, SN2, SN1, all that stuff. All right, so this is the start material, and I'm going to add HBr to it. Right, under normal circumstances, let me get a little blank spot up here. Under normal circumstances, if you took a alkene and added H, let me put a methyl group. If you took an alkene and added HBr to it, what would you get?
Do
Do you remember this from part one?
The double
It's
bond.
electrophilic addition.
Wouldn't
Yeah.
you get OH on one and BR on another or something?
Where's the OH gonna come from? Or did you say H and then BR? Yeah.
Mm-hmm.
Isn't the double bond will act as a nucleophile and will take the H
Mm-hmm.
and then
Come on, Sage. Bless us, bless us with the burning sage. Come on here.
so that happens. Be honest, I'm not sure where it goes right now, but then the BR will act as a leaving group in
So,
order to attack.
what you're saying is the double bond is going to attack here.
Yes,
You're going to break the HBr bond,
correct.
and it's going to undergo Markovnikov addition, right?
Mm-hmm.
Where the plus charge is going. This is the intermediate now. The plus charge
Okay,
is
and
going
it
to
will
be on
act
this carbon,
most substituted side.
right? And then BR is going to come in and attack here.
Yes,
Is that right? So you
correct.
end up with this as your product, right? And the H is on this carbon right here because this is CH2 over here,
Mm-hmm.
right? That's under normal circumstances. But it happens a little bit differently with conjugated dienes, and then we're going to talk about that. So with HBr, what we're going to do is add it. So let's put the arrows in. And that. So the double bond is still going to attack the hydrogen, and you're still going to break the. Ooh, that's sloppy. You're still going to break the HBr bond, right? But the intermediate matters, right? The intermediate is going to be different. And keep in mind, we're using this double bond right now. We could use either one of them, but we're starting with this one because it's a diene, so you can attack from either side, right? So this is going to stay intact. Uh-oh.